All right, so from the polynomial homework that we assigned, we identified the problems most. We're going to come back and talk about 7 and 10 in a different video because that was kind of something new we talked about today, even though it wasn't new. But we're going to address that differently. Right now, I want to make sure we can do 5, 6, and 9. That is our complete focus. As an aside, when you go back and check this, if the key was up there late for you, make sure when it's subtraction. So these two up here, these 4 up here rather, were all about combining like terms. You didn't have to use any of your exponent rules on these 4. None at all. All you did up here was add and subtract. However, on numbers 3 and 4, you must change every sign to the right. You must. If you do not, those answers will be wrong. So, where we're really seeming to having our biggest problem, which is not unusual, is multiplication. Just to make you feel a little better about yourself right now, not too much, but a little bit. The reason multiplication is harder is because it involves 3 things. It first involves multiplication, which involves your exponent rules, and then it involves combining like terms. And you have to know when you switch from each one. So we will start here. What we have here is a monomial times a trinomial, and we actually took notes on that. If you need to go back and look, I'm not saying right now, I'm just reminding you. And so that means I take this outside term and I multiply it by every term on the inside. Every term. I'm going to write that part out because we're not really good enough yet to where we do that in our head. Some of you are, and I know who you are, and it's okay. But I'm just going to write it out. That means what I'm doing is I'm taking 5x to the third times 4x to the fourth. That's the first one. Then I take that 5x to the third and I multiply it times negative 3x. And then finally, I take that 5x to the third and multiply it times positive 1. Now, I think this is where the confusion thing is. If you need to put plus signs there to remind yourself, you can. I don't do it that way because then I end up with plus and negative, but that's preferable than you getting mixed up. All right? There is supposed to be a plus or a minus that's eventually going to be between all of those, right? So we'll start with 5x to the third and 4x to the fourth. We start with our coefficients. What's 5 times 4? Then I do, now notice there's no plus in between these, right? There's no sign. So x to the third times x to the fourth is, do I multiply or add the two numbers? Why do I add? Is it a power to a power? No. That means same base, multiplied, add the exponents. So x to the 7th. Now, I'm going to do my green one. Start with your coefficient. 5 times negative 3 is, so there's your minus right there, right? So minus 15, not minus negative, just minus. And then x to the cube, there's an understood 1 right there. So what is x cubed times x to the first? X to the fourth is correct. And then we do the last one. 5x to the third times 1, what is that? Is it positive? Yep. And guys, now I have completely adding and subtracting. There's nothing left I can multiply. Are any of those the same exponent? Done. That's your answer. All right? Yes, ma'am. The 1 was times the 5x to the third. Good question, though, right? Because anything times 1 is that number. But excellent. Those are the kind of questions. Again, that was another good example. Because if you don't understand it now, it's not going to make sense later. That was good. Very well done. All right. Next one. Yes, yes, yes. It's all about once we get to adding, subtracting, and that's all we have here, right? Do you agree? We're no longer multiplying. These have to be identical or you cannot add or subtract them. And I know we did a lot of reasons why that, and like, it's one of those things, if I asked you in a really long question, you would tell me why we can't add and subtract it. You're just mixing rules up when you're putting it together. Because it's just a bunch of x's, right? I mean, that's what's going on. Yes, ma'am. Absolutely you would. Absolutely. Every sign to the right gets changed, not just the first one. Good. I'm glad you went back and made sure you understood that. So now let's look at number 6. Number 6, you can either use FOIL or you can use double distributive. I don't. This class I think preferred double distributive. Am I right? Right? Because I did FOIL and I'm good with that. So double distributive says we're going to start with this x and we're going to multiply it by the first term. What is x times x? And some of you are saying, this is why I'm struggling with polynomials, because I was struggling with my exponent rules. Do you see how everything builds? And not everything we do, like when we do the next, I'm not going to lie, the next thing we do has nothing to do with anything else we do. Dimensional analysis has nothing to do with this, not really. But what we've been doing so far, the reason we took that day and did exponent rules was because, can you imagine doing these polynomials without them? No. All right. Then I'm going to take this x, and by that last term, which is negative 6. So what is x times negative 6? That's exactly right, negative 6x. Now, I'm done with the first term on the first set. I'm going to go to the second term on the first set, which is a pho. Then we're going to do pho times x, which is that plus or minus? Plus. All right. And then I'm going to do pho times negative 6, which is negative 25. This is a check area for you. Before you combine like terms, if you have a binomial times a binomial, then that means you should have 4 terms down here. Before I combine. That should be a check spot for you. The people who did the homework tonight, a lot of you just did like, you multiplied the first and the last. You did x squared minus 24. The minute you were down to 2 terms before you combined, that should have been a red flag. I'm just trying to help you as you're going back to know where you're going wrong. So then the last thing we do is combine our like terms. Negative 6x and 4x are like terms. So x squared I just rewrite. And what is negative 6x plus 4x? And negative 24. X squared minus 2x minus 25. 9 times out of 10, this is not going to be true all through academics. But right now, so this is not a math thing. This is just a realistic where you're at. Almost all of yours, with the exception, like I would say 9 out of 10 times, after you combine like terms, you're going to know what the trinomial is. You start out with a binomial. All right? Just to help you while you're learning. That's not a math thing. There's all sorts of ways I could do it so that isn't the way it happens. Right? But I just want to give you that heads up. Someone hit the person who's got their eyes closed that looks like they're sleeping in my class. I don't want to call them out on name by video. But if they don't show up at home, their parents may go looking for them. All right. The only thing that made number 9 harder, was we were dealing with coefficients as well. And when that happens, you need to, I talk to myself in math. It's gotten worse now that I've been a teacher, because every time I work a problem, I don't work it just to get an answer. I work it to how I would explain it. So it really slows me down. It really is kind of scary. Someone could ask me 5 plus 3, and I'd be like, look, you have 5 apples and 3 apples. I mean, that's really where I've gotten to in my life. But maybe not quite that basic. Maybe for some people who are sleeping, I have to get that basic. I don't want to mention any names. You know, it's bad when the drool is literally coming down the cheek, the chin. All right, so we're still going to do double distributive. I'm still going to start with 6x, and I'm still going to multiply it times 4x. Start with your coefficients. What is 6 times 4? Good. Now do your variable part. What is x times x? So there's your first term. Now do 6x times negative 1. What's that? Negative 6x. Now we go to our negative 3. Remember, you've got to do the entire term. If it's a positive, that's great. But if it's a negative, it's got to be a negative 3 you're multiplying by. What is negative 3 times 4x? Good. And what is negative 3 times negative 1? Positive 3. My little check. Do I have 4 terms? Check, check, check. Good. I feel like I'm doing things pretty good right now. I feel pretty smart. I may not be, but I feel that way. And then it's just about combining like terms. I've got those two guys, or girls, 24x squared minus 18x plus 3. Yes, ma'am. Then when you multiplied, you called that negative. Is that? Oh, you got what? Say that again. You got plus negative 3? That's what I got, plus 3. Did you get these 4 right here? So then you got this line right here. Then all that's left to do is combine your like terms. You're not multiplying anymore. Can't do it. Can't do it. And isn't that interesting? You're the one who told me, and that goes to why it's important to talk to yourself. You've told me every time. You're the one who got it right on the quiz because I saw you going, yeah. That I can't do x to the third plus x squared. I can't do 24x squared minus 18x. It's got to be same base, same power. Must be. I wouldn't say you have to. That's a really good question, the way you asked me that. It's not that you have to separate it. What you do have to do is, if you'll say it like I did, then you won't get confused. Some of you get so excited about the x's, you forget about the coefficient, or vice versa. I'll have people give me x to the 24th here. I'll have people add the coefficients. A lot of you have done that on accident. So that's why, good. So because this right, so the first one right here was 6x times 4x. 6x times 4x means 6 times 4, which is 24, and x times x, which is x squared. And now they're still all multiplied together. Because order of operations, I've got to multiply before I add and subtract. And once I multiply, they're not like terms. You can't add those two because there's no add between them. These are all good questions. Yes, ma'am? Just because you guys had a lot more questions, I'm going to do number 8 as well. All right, that's what today was about. So we're going to add number 8 in. I wonder if anyone makes it all the way through this video. I will find out tonight. But let's go ahead and do number 8 as well. And that way you can look at yours and see where it is. Because I can see that with the coefficients is where this particular class is struggling. So it's still double distributive. I'm going to start with my 3x and my 2x. And this goes back to exponent rules. If you need to write each of the multiplication out, you can, but this goes back to exponent rules. So 3x times 2x is multiply your coefficients are 6, and x times x is x squared. So that's 6 times x squared, and we just write that as 6x squared. That means I have 6 of those x squareds. If this remote is called an x squared, I've got 6 of them. If this is an x, I'm looking to see how many of these I have. Okay? I can't add them together because what would that be? A highlight remote? A remote? A high remote? That's not nice. All right, so now I take the 3x times the negative 5. And that's going to give you negative 15x. Good so far? Now we're done with 3x. Be cool. We're going to go to 1. What is 1 times 2x? Positive or negative? So plus 2x, right? And 1 times negative 5? And I only have 2 like terms here. I only have 2, same variable, same base. And for those, I add the coefficient, which means I end up with 6x squared. This was a check. I had 4 before I combined like terms. But after I combined like terms, I had negative 13x minus 5. I have a trinomial, which is what I told you would normally have. Yes, ma'am. Mm, You're trying to multiply again. Don't multiply. This is adding and subtracting. When you're adding and subtracting, you keep that. I think that's exactly where whoever was asking me over here is coming from too. When I add and subtract, that means like put a different word in for x, and I think it will help you when you add and subtract. And I like to use money. All right. I owed someone $15. Instead of x, I said dollars. Right. I owed someone $15. I paid them back $2. Hey, now I only owe them $13. I didn't change this at all. I can't say I owed them $13 times 2. What did that even mean? Nothing. With x, do that. So when you're adding, subtracting, you can do anything, right? I owe. Money's my favorite. That's when we did integers. We always talked about money because people can understand it and they didn't understand the rules. I don't know what it is. We start talking about money, people get serious. Right? Which is why, right, when someone tells me, but I just missed a sign, I'm like, that's a big deal. Right? Negative 500 and 500, that's between you owing me 500 and me owing you 500. And that's a big deal. To me, that's $1,000 difference. I take that seriously. I want you owing me the $500. Actually, I'm fine with that. All right. I can't find the stop button.